Let's start. Exercise 5I. So assuming that you now have mastered your exponential and logarithmic algebra, you've also studied the graph, now is applying. Applying means you can use your CAS and you do need to know the graph's properties, and therefore you then model the situation. Now in terms of modeling, I do know there's a lot more formulas that you can follow, but in general, I think you just need to know these two. Technically, you only need to know one, but I found that students find the example from your textbook a bit tricky to understand. One is called cell growth. Specifically, this is the equation they're giving it. This cell growth only applies for cells that split in two. Okay, that's why there's a base 2. Because you're saying for every minute it doubles itself. So therefore, after 3 minutes, it would have doubled itself 3 times. Okay, so it has to be the split in 2. Then you'll be using a base of 2. What I think students get confused about is when the question asks for generation time. Say if a cell splits, so you start off with one cell and the cell splits up into 2 after, say, 5 minutes. Right? Then in 1 hour, see logically, in 1 hour, which is 60 minutes, how many times would have it had split itself? If every 5 minutes it's going to split itself, in 1 hour, how many times will it split itself? Logically. 12. And this is where, if I asked you, how'd you get 12? You would have said, well, you said 60 minutes time in 1 hour, so every hour. If you split yourself every 5, you're going to take the time divided by 5 minutes. See that? So I'm going to write it again. So you're saying 60 minutes is the time, so duration, and you're dividing by 5 because this is what they call generation time. So when I asked you how many times does it split up in an hour, and you said 12, the logic was you said how many 5s fit to make 60. That's what this formula is saying, which I find that students find confusing. But logically, you knew how to do it. But when I put it into a formula, students find that disconnection. So that 60 is the time, the duration that you are looking at. But then what is the generation time? So how long does it take before it splits? Some questions could be 15 minutes. Every 15 minutes it splits. Every 3 minutes it splits, or every minute it splits. So then you got to figure out what would the rule be to get there. And it literally is just the duration divided by, well, how fast does it take to split? Okay? So that's the only part that I find students not understand when they're looking through the textbook. So generation time literally just means how long does it take to split a cell? Okay? So here's an example, just so that, this is a textbook example. If you're reading into it, trying to understand it. This says, what is the generation time of a bacterial population that divides into 2? So that's a key word. So we now know it's base 2. So it splits into 2 every TD minutes. So we don't know the generation time. We don't know how long it takes to split up into 2s. What we do know is it increases from 5,000. So you start off at 5,000 and you end up with 100,000 after 4 hours. So if I write it down, you started off with 5,000, you end up with 100,000, and it took you 4 hours. But remember, generation time usually is in minutes. That's at least the way the textbook writes it. So it's usually in minutes. So we need to convert the 4 hours into minutes, just like how I converted 1 hour into 60 minutes. Yeah? So 4 hours into minutes, times that by 60, that's 240 minutes. So and if you don't know how to model it, then you can use the template they've given you. To me, it's pretty straightforward. You got your starting value. It's a base 2 because it splits up into 2. And, it's duration divided by generation time. Yeah, so this should give you 100,000 is equal to starting off with 5,000, splits into 2, duration was 240, and you don't know what the generation time is. And now you got yourself an equation to solve. Again, you can use a CAS to solve it, but I also want to see if you can do it by hand. So let's test your algebraic skills. Let's start off with Adonis. Eventually, I want to find TD. Okay? What's the first step? Good. Divide both sides by 5,000 since it's times 5,000. And 100,000 divided by 5,000 is the same thing as saying what's 100 divided by 5. Okay. 100 divided by 5 is 20. 20 equals to 2 to the power of 240 over TD. You're trying to find TD. Back to this spot. How do I find, or how do I get rid of the exponential? Let's go back to Una again. So last session I asked you this question, see if you've learnt it. How do I get rid of base 2? What do you do? Log base 2, very good. So opposite of exponential is log, and since that's the base 2, you do log base 2 on the left, log base 2 of the right. Log base 2 and 2 will cancel out their inverses, and you end up with 240 over TD is equal to log base 2 of 20. All right, our goal is to find TD. Vibha, what do I do now? Very good. So there's lots of ways to solve this problem. You could do the inverse. So if you just swap TD to the top and 240 to the bottom, so numerator, denominator, if you just swap them, then that means you'll swap the left-hand side as well, and you can end up with 1 over log base 2 of 20 is equal to TD of 240. So you're doing the reciprocal on both sides, or essentially what I'm doing is I'm saying take 1 divided by the right and 1 divided by the left. That's essentially what I'm doing there. Okay, or for those who prefer, you can do times TD on both sides and then divide both sides by log 2 of 20. You still get the same answer. Okay, so if you swap it around, and then now you can see that's divide 240 times both sides by 240, and that's how Vibha got TD is equal to 240 over log base 2 of 20. Okay, and then with your CAS calculators, you can type log 2 of 20. If you have a scientific calculator, the only difference was in this step here. You'd have to use log base 10 or log base E, and then use log rule number 3 to then rearrange it. Okay, so for those who weren't sure, this is what you could have done as well. You could have done log base 10 of 20 on the left, log base 10 of 2 to the power of 240 TD on the right. Since these don't cancel out, this is when you use rule number 3. You can drop down the 240, so then it becomes 240 over TD times log base 10 of 2. That's using rule number 3. On the left-hand side is still log 10 of 20. And then now you're back to the same thing, just divide both sides by log 10 of 2. And you're back to where we left off with Vibha before. Okay, so right there, you could also type on your calculator, our scientific calculator, TD is equal to 240 times, this would be now 240 times log 10 of 2 divided by log 10 of 20. And you'll get the same answer. So if you don't have a CAS calculator, do that. You can also do it on a scientific calculator through this. But what I just did there is showing strong algebraic skills. Okay, so it means you have to be able to do both. You have to be able to do it doing this way if you had a CAS, and then do it this way if it's not a log base 2, it has to be log base 10 or log base E. Okay, both of which you need to know how to do. Cool? All right, what does that work out to be actually? I wrote down the answer before. Type in your calculator and you should get 55.53077 minutes, because you're working out the generation time, which is approximately closer to 56 minutes. Okay, so it means that the cell splits itself every 56 minutes, roughly. Okay. All right, flip over the page. So that's a typical textbook example if you're trying to understand generation time. Let's have a look at a typical increase by percentage with exponentials. Example 2. Population of 2,500 lizards increases by 30% after every 4 months. Write a formula that gives the number of lizards after t years. So notice the difference there. One says every 4 months, and this one, t, is the duration in years. So how many 4 months are there in years? Well, every year, if there's 4 months, that means there's 3 groups of them. So what type of growth or decay? This is clearly a growth scenario because it's increasing by 30%. How much are you starting off with? Well, it says 2,500. So you start off with 2,500 lizards. Now here's the only part you got to think about. T years. If it was 1 year, then how many times did it increase itself? It would have been 3 times. So that means whatever t is, you're going to times it by 3. So here you should write 3t. 3t because it's every 4 months. So it's going to increase by 30% every 4 months. So it happens 3 times every year. And so depending on the number of years, you're going to do 3 times that amount. So if it's 2 years, it'll be 6 times. If it's 3 years, it'll be 9 times. Yeah. So to model now, we can write it out. You start off with 2,500 times. Now, anyone know how to fill in the base? How do you say, starting with a certain value and you increase by 30%, what goes in the brackets? Because we know it's going to be to the power of 3t. 1.3. Now, why is it 1.3? Why is it 1.3? What's the logic?
30% of 100%. I don't know how to
Yes, well, Leo, you are correct. Sima, you were going to say?
I was just going to say, like, your initial value, which would be like 100%.
Beautiful. Adding, which is what you were saying. So you start off with the original amount, which is 100% of itself, and then you're increasing it by 30%. So overall, it's 130%. So this is your typical formula. If you've learned compound interest back in year 9 and 10, it was 1 plus, and then plus or minus. So growth is up, plus, and decay is minus. And they usually say R over 100. But you don't need to memorize the formula. Logically, it makes sense. 100 is itself, adding on 30%. So 30 over 100, that's why it's 1.3. Okay. So question, what's B? B, how long does it take for the population to reach 15,000? So now I've got a formula. 2,500 times 1.3 to the power of 3t. I know that I want to figure out when it reaches 15,000. And again, from here you can use a calculator. You can also practice using your CAS. Yeah. This one. This is a general exponential equation. Yeah, so they will give you only use E when they usually have to specify to you that it's a natural exponential growth. Then that's the hint that you use E. Percentages usually will start off with 1 itself and then add it on percentages. Anything that doubles itself, base 2, triples itself, base 3. So they usually will give you a hint that it is going to be base E. And that's probably the only challenge with exponential applications is when you're reading the question, what base do you use, is the first step. Okay, so when it comes to percentages, yeah, it'll be just 1 plus or minus. And the only time you use E is when they say it grows exponentially without saying any other percentages on itself. Yeah. They usually make it pretty straightforward. Otherwise, they'll give it to you. All right, so from here, we now got this. And again, you can type it in your CAS and solve for T. Did I do it by hand in my own calculations? Let's see. What did I do? I just used CAS. All right. Use your CAS, and you should end up with 2.2764 years. I'm not done yet. What's the question asking? Yeah, they want years and months. Now the question is, because I find it's interesting, not all students know how to convert it to months. What do you do now? So clearly it's 2 years. How do you convert the 0.2764, whatever it is, to months? What do you do? Times by 12. Okay, because this is in years, the unit's in years. If you want to convert 2 years to months, how do you do it? 2 years times by 12 gives you 24 months, right? So then you take 2.2764 times by 12, but since you already know it's 2 years, you only need to know this bit. What is 0.2764 times 12 in months? Yeah, so on your calculator, if you want you on how to do that, that's one that I find in the SACs, and all that students don't know how to convert it. Type in your calculator, and you should end up with 3.3 something, which is closest, because it says nearest month, 3.3. Well, there's an argument here. I think last year's group was asking, do you just round it up because you passed the 3 months mark? But because it says nearest month, I would argue that it's 3 months. Okay, so 2 years and 3 months because it says nearest month. But I can see where they're coming from as well, because after you pass 3.3, well, the next nearest month is 4 months. So they will say 2 years and 4 months. That's where it will get a bit sketchy when it comes to your exams, but for your SACs, we'll be pretty straightforward on it. We'll be pretty clear. Okay. All right. This is Mr. Bagier's question, which I liked. Looks intense, but if you picture the problem and try to figure out the problem, it shouldn't be too hard. So I'm going to give you, use a calculator as well. I'll give you 5 to 6 minutes to solve this problem. And then, all right, so let's read the question. It's the intensity of light. Okay, so we've got I for intensity, how strong the light is, d meters below the surface of the sea. The nice thing is they've given the models. Mr. Bagier has the model there ready for us. And one of the key words was the intensity of light is halved. So wherever you start off with, it's halved when a diver is 5 meters below. So I start off with the model that was given. When d equals 5, it should be half of what you started off with. Okay, so putting it in, I intensity is half of original is equal to original times e to the power of, and d is equal to 5, so it becomes 75k. So that's your starting point. And then what you should realize is that from this step, you just take all of the exercises. Since they're both times I naught, you can actually divide I naught on both sides, and that cancels out. And you end up with half is equal to e negative 5k. And then from there, you can use your CAS or you can do it by hand. And you should get, I just logged e on both sides there. So log e of half is equal to negative 5k. Divide negative 5 on both sides, and k should equal to this. What I also did was, just because I didn't like writing the half, I just used rule number 4. Bring the negative 1 as a power, and half to the power of negative 1 is the same thing as 2. Okay? Well, the reciprocal of half is the same thing as 2. And I just did that just for myself, because I just wanted to write 1/5 ln 2 rather than 1/5 ln and then another fraction. So that was my personal thing. Which works out to be about 0.13862994, but the question says 4 decimal places, so you should write 0.1386. Hands up if you got the first one correct. Okay, good. That's a good start. So getting rid of the I naught, that's a typical one, the exercise. Therefore, just writing the equation out, they said sub k from A into the equation, so B was pretty straightforward once you know K. Even if you didn't know it, I guess you could just still move on and try the next question. Okay. Next question, C. It tells you that find the percentage of light available. So when D equals 10, I already got K. I subbed in 10, and then I worked out this value. So you type in your CAS, and it works out to be 0.25007360. And if you read and interpret this, which is the point of the question, did you understand what it meant if you started with I naught and you times it by 0.25? That's the same thing as saying you're quartering it. There's about 25% left over. So the question was, what's the percentage of light intensity left over or available? 25% of the original is what's left over. That's what's available. So you think about this diver going down the sea. Going down the sea, the person dives down. Okay, they're diving down. We can see that the light intensity must decrease as you go. And what it's saying is when it reaches a depth of 10 meters, the light intensity is about 25% of the original. That's what it's trying to say. So if you understand that on a pictorial point and understand the problem, then D becomes easier to understand. So if you read D now after picturing it, D's asking if artificial light is necessary. So at some point you need to use artificial light because you can't rely on the light from the surface. Then the only time you start using it is when the intensity is less than 0.1. 0.1 is the same thing as saying 10%. So it's just saying less than 10%. When will you have 10% of the initial light from the surface? So in this question, this is my model. When is the intensity of the light less than 10% of the original? That's when you use the artificial light. So I drew the graph. I said, well, this is the graph. This is a negative, so it's just a reflection in the y-axis. This means the more you go depth-wise, the light reduces. At the y-axis intercept equals to 1. But what does 1 mean? 1 means 100% of light from surface. We're looking for 0.1. So you can find the intersection of when 0.1 equals to the equation, or you can actually type in literally this bit. And then it'll work out for D. So if you CAS it, you should get this step, and then D is greater than 16.613. Or if you did it graphically, you should also find the intersection, and clearly D needs to be greater than whatever that number is, that intersection is, and then you would find it's greater than 16.61 meters below sea surface. That's when you will need to use artificial light, based on Beziers' problem.
If you have to graph it, would the domain be from 0 to 100?
Yeah.
It wouldn't be the-
I was just drawing it, like a quick drawing, just to visualize what's actually happening. And that's how I usually think of these applications. I'm like, here's a model of what's realistic, and you're correct. If it was a sack and asked me to draw, I wouldn't draw that on side, because it wouldn't make sense to have negative depth. Or you could. It might just mean above surface then. All right, there we go. So that was Beziers' problem. I thought it was a nice one. It kind of ties in with the exercise about getting rid of the initial and not needing to know the initial. You can still solve the problem. But that's chapter 5, team. I'm going to stop the video there. Hopefully that was a nice problem.